Welcome to week 5 of software engineering. Let's get ready. Let's go ahead and jump into the deep end. Okay, today and this week, we're going to be discussing and talking about testing. Specifically, we're going to be talking about verification versus validation, talking about levels of testing, talking about the test design techniques, and somewhat on automated testing and what that buys for. Also, software quality metrics. How do we measure whether we have a quality product? Excuse me. Okay. So that is what we're going to be covering this week. Let's go ahead and get started. One second. Oh yeah, here we go. I did want to kind of go over this. This testing is not just about finding errors. It's about building confidence in the software, ensuring reliability, and protecting the reputation of both the product and the team that developed it. So this is another look at why we test. Okay, that it could be a reflection on you as being one of the developers of the application. If you basically deliver a product, okay, that is not good, primarily due because it wasn't tested. Okay? So just wanted to bring that up and highlight that it's something we want to keep our mind on. Okay, verification versus validation. Verification, are we building the product right? And I would flip though, this with validation first. Validation, are we building the right product? Okay. What determines whether we're building the right product, okay, is in the requirements. The requirements tells us what we should be building. Verification says, okay, we know we're building the right product, but are we building the product right? Okay. Are we basically doing and producing it the way it should be produced? That's what we're designating here. So validation, are we building the right product? Verification, are we building the product right? Okay, verification. Okay, are we building the product right? This particular diagram is showing that one of the ways we can do that is via inspections. And inspections are here, so software inspections, they involve people examining the source, the representation with the aim of discovering anomalies. Inspections do not require execution of a system and may be used before implementation. They may need to be applied to any representation of the system. So going back here, okay, here all of these items or all of these methods are candidates for inspection. You know, looking at the requirement specification, are they right? Software architecture, are they right? Unified model language, is it right? So here we can manually look at these pieces of the system and determine whether they meet the requirements that they're supposed to meet. Inspections are a great way of doing that. Validation testing. Validation testing is, we have the right product, okay, we have the right methods, okay, with the verification. Validation says, are we doing it right? Okay. Or do we have the right product? Excuse me. You say you're going to get confused. I get confused on something. Okay. But the basic thing with validation is this. We have a system. We're basically going to input data into that system, and we're going to see what comes out. Okay. The information that we put in the system, we're putting the information in there so that we can cause failures. There is no guarantee that if we put in some data and it comes out and there's no errors, that in itself is saying that the product is correct. Down here, one thing, hold on, where is it? Okay, testing is intended to show that a program does what it's intended to do and discover program defects. When you test software, you execute a program using artificial data. Here it is. You can reveal the presence of error by testing, but not the absence. You can never be in a position where you can go to the user and say there are no bugs in this software. Yeah. You can say that we have covered, 90% of the code in there and we couldn't find one, but there is no guarantee that you could ever get through all the bugs and go to the user and say that this code has no errors. Okay? So that's here. This is important. Remember, can reveal the presence of errors, but not the absence. Okay. Other things, when you test software, you execute a program, you check the results of the test runs for errors, anomalies, about the program's non-functional attributes. Testing is part of a more general verification and validation process, which also includes static validation techniques. And that's one of the things it's talking about with inspections. Here's a model of software testing. You design test cases, you prepare test data, you run the programs with the test data, and you compare the results that came out of the test with what you were expecting. Remember, there's two pieces. You have what comes out of the test, but before that, you have to determine this is what I'm expecting to come out of this particular test. That's where the comparison of results comes in. Here are repositories. When we design test cases, we put them in a repository, which feeds the next step. Just preparing the test data, we put it in a repository to run the actual programs. Here, test results, put them in a repository, we compare the results with our expectations. And then we put out a test report. Okay, levels of testing. Here are the main levels of testing. Unit testing, test individual components or functions. Not looking at any interfaces, is this program working right based on the specification, based on the requirements. Integration testing ensures that the modules work together. I have two programs, they're talking to each other. Is that interchange, is that interface working correctly? System testing validates the entire system in the end. This is a test that covers the entire system. It covers all interfaces, all unit testing. It's basically a system test that before we put this application into production, have we performed a system test, which is from the beginning to the end. Acceptance testing confirms that the system meets the user requirements. Most of the time, well, not most of the time, all the time, before a system is put in production, you go through acceptance testing. Acceptance testing and system testing may be close, but they are not the same. Acceptance testing happens before system testing. Okay. So what we're doing here is we're just running tests that the user usually develops. These acceptance tests come from the user. I need to ensure that I can add a customer. I need to make sure that I can send an email. I need to make sure. These are tests coming from the customer or the user, okay, interchangeably, coming from the user that validates based on what they want out of the system, it works. That's an acceptance test. To me, regression test is probably the most needed or most useful. It ensures that changes made to one part of the system have not adversely affected the unrelated part of the system. When we are developing systems, we'll be making changes. Someone might say, well, look, I'm making this change. There's no way it's going to affect, module ABC because it never touches module ABC. Okay. But what could happen is I changed module 123, which calls module 12A, which calls module 12B, which calls modules 123B, C, and then eventually ABC. Okay. So I may have changed something in the process of making a correction, which inadvertently, I didn't mean for it to do, but inadvertently caused something else to go wrong. Regression testing, the purpose of that is to make sure that the change that I made hasn't affected any other thing in the system. Unit testing example, test a single method or class in isolation. Again, these are just examples of tools that can be used to do the unit type testing. Example, testing a calculator's add function, make sure it's returning the right value. Integration testing verifies modules and services communicate correctly. There are some tools that can be used to help in doing that as far as integration testing. System testing, test complete integrated system. These are some tools that are available. Selenium, test complete, manual exploratory testing. For example, run end-to-end tests for flight booking system, including search, booking, payment. Okay, it's complete system test from start to beginning. Accepting testing, validate the system against business requirements. Performed by end users. I said that's the key thing, that these acceptance tests are performed by the user and not by the technical gurus. Okay, black box. This is a type of testing where it focuses on functionality without knowing the internal code. When I input like the calculator we were just talking about, if I enter a calculator and I want to make sure that the add works, then I will input into the black box, add 2 plus 2. I know my expectation is 4, okay, but I'm not going to know what kind of code is being executed. I'm going to put in 2 plus 2, and if it comes out with 5, it's saying there's a problem. Yeah, that's what's here, that the functionality coming out of the black box is solely based on what we anticipate the result to come out with. Not looking at any of the logic within the program, but simply, here's my input, here's my expected output. Did I get my expected output? So that's what we have here. Focuses on functionality without knowing internal code structure. Tester provides input, validates output. Strengths, unbiased testing. The tester doesn't need to know a programming language. Help validate requirements and user expectations, effective for large systems and user interfaces. The weakness, you never can tell whether you covered all the code that you wanted to cover in order to make sure that there's no bugs. Okay, there's no guarantee. Since it's black box, you're basing it simply on functionality and not on programming lines of code. Now, white box is the flip side. White box says I'm going to test based on the code that I have within the program and not based on the black box concept. Focuses on internal logic and code structure. Requires programming knowledge to design the test. And for me to make sure I go through some series of code within the program, I have to know the program. Okay, and it's not something that a user can do. It's not. There's no such thing as a white box acceptance test. Okay, because the users are not going to be expected to know what the code is within the program. White box testing provides thorough coverage of logic and paths, helps optimize code, find errors, useful for security. Okay, the weakness is requires detailed programming knowledge. Can't run a white box test if you don't know what's in the program. It's time consuming for large systems and may miss higher level functionality issues. Okay, things that can happen that's not directly connected to a specific line of code. You're also going to have automated testing. This is really kind of a given that it's going to be needed. Unit testing, you can automate. Integration testing, you can automate. Later on in week 7, we're going to be talking about AI. Okay, we can have AI generate automated tests to basically be able to go through lines of code and make sure that we have coverage. What's not listed in here, okay, yeah, what's not listed in here is, let's go back. What's not listed here, okay, is regression testing. Okay, regression testing, we want to make sure that we haven't screwed up something based on some change. Okay. So the regression testing is ideal for automated testing. Okay. It's ideal. And it's ideal because you can pre-program or set up automated tests so that whenever you make any change, you run the automated test. Okay. So that is ideal rather than have to run tests manually whenever changes take place. Okay, black box, white box. Okay, automated. And all of these are candidates for automated testing. Okay, software quality metrics. Here are some of the ones that are most effective and used. Defect density, the number of defects per 1,000 lines of code. Now, if we have 2 defects per 1,000 lines of code versus 100 defects per 1,000 lines of code, that tells us something about the product, tells us something about the system. That 100, that density, if it's a high number or higher number, that affects on the quality of the product because a lot of bugs. Okay, a large density means a lot of bugs. Okay, so a number of defects per 1,000 lines of code, code coverage, the percent of source code executed by the test. If I run a series of tests and I'm covering 50% of the lines of code, then I have a problem. Okay, I don't have the coverage of testing everything that's in the program, and I'm not going to have that confidence from the user that a 50% source code coverage is giving me a good product. Say maintainability, ease of understanding, modifying, extending the software, reliability, probability that the software performs correctly. Those again, these two are directly connected with defect density and code coverage percentage. Here's just more information. Defect density, the formula, take the number of defects divided by lines of code. Code coverage, measure how much code is tested. Okay. The higher the number, the better we are. Maintainability, clear coding standards and documentation. Reliability, probability the software runs without failure. Okay, so that's kind of the overview of testing. We'll be doing some test cases for your project, and at least try maybe that. At least try. You will do at least 1 or 2 quality metric type activities on your particular project, and so we kind of reinforce what we have here as far as what we're trying to do with testing. We're not trying to tell the user that there are no bugs. What will tell us that is if we have a high lines of code coverage and we have a low defect density. Okay. So we can tell that and give that to the user in metrics rather than saying, this system we tested it, it's good. It's better to be able to say, hey, here's the metrics that shows the quality of the product that we built. Okay, we will see you in class in person or on the forum discussion board. Everybody have a good one.